All right, we're going to deal with worksheet 3, which is understanding the relationships among velocity, speed, and acceleration. Okay, so as we talked about last week, speed is the absolute value of velocity. It tells you how fast something is moving without regard to the direction of the movement. So very simple questions. What effect does absolute value have on numbers? You guys should know the answer to that. Pause and fill it in and then come back. Some of you guys might have said that it turns answers positive. I want to make sure that we understand that it makes values non-negative. Okay, so the absolute value of 0 is 0. That's not a positive number, but it'll turn all negative numbers positive. It keeps positive numbers positive. It's a follow-up question. It asks, what effect does taking the absolute value of a function have on its graph? Think about it, pause, fill it in, come back to me when you're ready. Okay, and so if you take the absolute value of a function, the graph, any negative values will become positive. So if there's anything that lies below the x-axis, it will reflect over the x-axis, or flip it over the x-axis, everything becomes exclusively positive. Okay, all right, so now there's a couple situations that it's going to go through. So for each situation, it's a differentiable function giving velocity as a function of time, just on the interval from 1 to 5. It's given selected values of velocity in a table. On the graph, each horizontal grid mark represents 1 unit of time. Each vertical grid mark represents 4 units of velocity. And so we're just going to go through here. So now, if you guys can fill in the table, this first one seems very redundant. You guys see, so I have time 1, 2, 3, 4, 5. I have velocity at each of those times in this column right here. And we just want to figure out what the speed would be. Well, if velocity is 1, speed is also 1 because speed is the absolute value of velocity. If the velocity is 2, the speed is also 2. If velocity is 4, speed is 4. If velocity is 8, speed is 8. If velocity is 16, speed is 16. Okay. And then I just want you to pause and fill in the information in the paragraph. The words underneath are the word choices to fill in for that particular blank spot. So in this situation, the velocity, you guys can see, the velocities are all positive. I'm just going to use these markings instead of writing words. And the velocity graph, is it increasing or decreasing? It's definitely increasing. Okay. Because the velocity is increasing, that's what we just said, we know that its derivative, which we call acceleration, is positive, okay? By examining the graph of speed, and it asks you to draw speed, I'm sorry. So first it says to plot speed on the same coordinate plane. Well, it's going to match perfectly, right? Because that speed is the absolute value of velocity. So by examining both the graph and the table of values, look at these values. They're going from 1, 2, 4, 8, 16. They are increasing, okay? So here we had both velocity positive and acceleration positive, and we had speed increasing. Okay, let's look at situation number 2. Okay, situation 2 looks totally different, and it lies below the x-axis. So the first thing I want you to do is draw what the speed graph would look like. Okay, or again, speed is the absolute value of velocity. Pause the video. When your graph is done, come back to me. Okay, and what you should have drawn would have looked like roughly that. Okay, not perfect, but it just flips it over the x-axis. Now I want you to pause and fill in the values of the table for speeds, remembering that speed is the absolute value of velocity. Okay, when you're ready, just come back to me. So I'm just going to take the absolute value of all these numbers, and so the absolute value -1, +1, and then absolute value -2 is 2, absolute value -4 is 4, absolute value -8 is 8, absolute value -16 is 16. Okay? All right, now I want you guys to pause, try to fill in the blanks in situation 2. When you're ready, come back to me. Okay, so in this situation, velocity, you guys can see the velocity. They're all negative values. Okay, look at the velocity graph. The velocity graph is down here. Is it increasing or decreasing? It's falling, so it's decreasing. Okay, because the velocity is decreasing, we know acceleration is the derivative of velocity. So when a function is decreasing, its derivative is negative. Okay, now let's look at the graph of speed. If you look at this green graph here, is that graph increasing or decreasing? If you look at these values here, they go from 1 to 2 to 4 to 8 to 16. Are those values increasing or decreasing? They're increasing, okay? So we have a graph where velocity is negative and decreasing. Now, remember we talked about how negative 10 miles per hour would be slower than negative 55 miles per hour. But if I think about just the speed that you're traveling, 55 miles per hour is faster. You guys see how this is a decrease in value? It's just confirming what we've talked about. So we are decreasing our values, and even because they're negative and decreasing, we're actually speeding up. Our speed is increasing. Okay, let's look at situation number 3. All right, in situation 3, you're given this velocity graph and those velocity values. I want you to pause and draw what the speed graph would look like, where speed is the absolute value of velocity. When you're ready, you can come back to me. Okay, so the speed graph is just going to be flipped over the x-axis, so not perfect, but it looks roughly like that. Okay, now I want you guys to pause and fill in the speed values on the table. When you're ready, come back to me. If velocity is negative 16, the absolute value of that is positive 16. Absolute value of negative 8 is positive 8. And then I got a 4 and a 2 and a 1. Okay. In this situation, velocity is below the x-axis. The velocity is definitely negative, okay, because it's below the x-axis. But look at it. It's increasing, right? It's rising. All right. Because the velocity is increasing, acceleration, which is its derivative, is going to be positive or negative. It's going to be positive, right? When a function is increasing, its derivative is positive. Lastly, by examining the graph of speed, there's my speed graph. Is that graph increasing or decreasing? Is it rising or falling? It's falling, right? So it's decreasing. Look at these values. 16 down to 8, down to 4, down to 2, down to 1. Those are definitely decreasing values. Okay. Questions, message me. Let's move on to situation 4. All right, at this point, you guys should be going through this pretty quickly. Here is my velocity graph. If I try to graph my speed graph, it's just going to be a perfect overlap, because if I take the absolute value of things that are already positive, they're just going to remain positive. All right, so it's going to look the same. The velocity values, if they're positive, the speed values match, right? Because absolute values of positive numbers are still positive. In this situation, the velocity values are all positive. Okay, and look at the graph of velocity. The graph of velocity is for sure decreasing. Look at the values of velocity. Those are for sure decreasing. Okay, because velocity is decreasing, we know that its derivative is negative. Okay, but by examining the graph of speed, look at here, 16 down to 8, down to 4, down to 2, down to 1. Look at the graph of speed. That's also decreasing. Okay, I want you guys to reflect on this and try to fill in the conclusion part. When you're done filling in the conclusion part, okay, so pause the video, fill in the conclusion part, and come back to me when you're done with that. Okay, so in which situations was the speed increasing? That was in situations 1 and 2. Okay, and in those two situations, the velocity and acceleration, in situation 1, velocity and acceleration were both positive. In situation 2, velocity and acceleration were both negative. So when speed was increasing, velocity and acceleration had the same signs. All right. In situations 3 and 4, velocity was decreasing. Okay. I'm sorry, speed was decreasing. I misspoke. I apologize. Okay. In situations 3 and 4, speed was decreasing. In situation 3, your velocity was negative, but your acceleration was positive. In situation 4, your velocity was positive, but your acceleration was negative. I'm pretty sure. And so then we can say that they have opposite signs. All right, so the takeaway here is if velocity and acceleration have the same signs, then speed will increase. Oh, I just had to circle the bottom part. That's the big takeaway. That's something that's really important that AP will be asking you about. And then speed is decreasing when velocity and acceleration have opposite signs. Okay, for those of you guys who aren't appreciating this, the story I always tell about this is when I was little, and I used to have my little afro, and I used to torment my brother, who's 5 years older and like a solid foot taller than I am. Well, I guess he's not a foot taller, but it feels like it sometimes. There were a couple different things that happened. Okay, so here's my big brother. Very accurate picture. There's his hair. And here's little me. okay, with my afro. Okay. And there are two things that would happen. Okay. Sometimes I'd be running away from my brother and he would chase me. All right. So in this case, I'm running off to the right. So my velocity would be considered positive, right? My brother is going to run towards me and he's going to push me. He is a force acting on me in the same direction I'm running in. Okay. That force is called acceleration. And because he's pushing me towards the right, my acceleration is also positive. Now, if I'm running to the right and my brother pushes me to the right, I'm probably going to fall on my face, but I'm going to lurch forward and go faster forward. If I'm running off to the left and my brother starts chasing me and he comes up and then he pushes me in the same direction I'm running in. So if I'm running to the left, my velocity is negative, right? Just because I'm running left. If he pushes me to the left, that's a force called acceleration that is also negative, okay? And that is also pushing me to the left. I'm going to lurch to the left, but that's going to speed me up, all right? So in either of these situations, speed is increasing, okay? So if velocity and acceleration have the same signs, we have speed increase. This is the same thing that you see if you have a car rear end another car. The car that's in front will move forward faster. It'll increase its speed because it's being pushed in the same direction that it's already traveling. Same situation here. All right. If, on the other hand, I decide to, and I did this way too many times when I was little, I used to run full speed at my brother, drop a shoulder, and try to knock him over. Okay. So now, if I do it in this direction, I'm moving left. Just because I'm moving left, that tells me my velocity is negative. If my brother is standing still, he is a force acting on me in that direction because he is moving. He's not moving, and I'm running into him. So he's pushing me in the opposite direction. Because he's pushing me to the right, my acceleration force is a positive force. Okay. Now, if I run full speed into my brother, I'm not just gonna hit him, okay, and go pink and then fall over, right? That's not what's gonna happen. If I run at him, he's going to move this way if I hit him full force, but he's going to slow me down, okay? So because I was moving left and I hit a force that was pushing me in the opposite direction, that caused me to slow down, okay? And it doesn't matter which way I run at him, okay? If I run at him this way, okay, just because I'm running to the right, suddenly my velocity is positive. Now, if he's standing still, he's gonna act as a force that's pushing me in the opposite direction, okay? Because it's a leftward direction, that force, which we're calling acceleration, is gonna be negative. All right, so again, I'm gonna hit him, and we're both gonna continue to move this way, but I'm gonna slow down dramatically because I've just hit this thing that's much bigger than I am. Okay, so in both of these situations that we slow down. So you guys are looking at it graphically, you're looking at it numerically, you're looking at it in terms of actual real life situations. I do not recommend running running into or pushing your siblings, but you know, if it's for science and math and discovery, then maybe you should. Okay. That is it for this video.